Welcome to this explainer. Look, if you're trying to truly master your Cambridge exams and stop leaving easy points on the table, you are in exactly the right place. Today, we're basically cracking the examiner's code on what is often considered a notoriously tricky topic. We're looking at using differentiation to find gradients, tangents, and normals in Cambridge additional mathematics, specifically syllabus 0606. We're going to move way past just crunching the numbers. We want to look at the underlying patterns, the actual strategies, and the analytical frameworks that the top-tier candidates use to completely ace these questions. There is no magic to this. It's just about seeing the code behind the question. Okay, let's dive straight into this massive number right off the bat. 15%. That is approximately the chunk of your total exam marks that this single topic accounts for. I really want you to think about that for a second. When a single area, like differentiation applied to gradients, tangents, and normals, holds 15% of the weight of your entire additional math exam, it instantly transforms. It goes from being just another chapter in your textbook to an absolutely critical make-or-break area to master. I mean, if you want that top grade, you literally cannot afford to leave these marks on the table. So to get you there, today's structured roadmap is going to give you the insider strategy directly from the Cambridge Principal Examiner reports. We're going to cover our core principles, the method mark strategy, a reliable 5-step process, crucial examiner warnings, and finally, achieving evaluated mastery. We're taking you straight from the foundational concepts all the way up to the ultimate evaluative thinking that examiners are actively hunting for on your paper. Let's start with Section 1, Core Principles, and building that conceptual foundation. It is absolutely vital we begin here because applying differentiation concepts to totally unfamiliar contexts is exactly where the vast majority of candidates hit a wall. You know, it's one thing to solve a practice problem you've seen 10 times before in class. It's an entirely different beast when Cambridge throws a completely novel, twisted scenario your way. The syllabus actually explicitly demands what they call a connected conceptual understanding. What does that mean? Well, examiners emphasize that top-performing students don't just memorize formulas or regurgitate step-by-step textbook rules. Instead, they exhibit a true mastery of fundamental principles. This is what allows them to seamlessly transfer their logical reasoning into totally unfamiliar mathematical contexts. They actually see the underlying architecture of the math. They know exactly what they're doing, whether the derivative is being applied to a basic quadratic equation or some highly complex trigonometric curve. So the academic benchmark we're aiming for here is analytical depth versus superficial breadth. Cambridge examiners are not impressed at all if you just know a little bit about a lot of things. They prioritize deep, evidence-based reasoning over a superficial, broad knowledge of the topic. They want to see that structured, logical reasoning mapped out right there on the page. You have to prove you actually understand why the derivative represents the gradient of the tangent, rather than just mechanically applying the power rule without thinking about the geometric reality of what you're actually doing. And developing that depth of understanding brings us right to the true secret for accumulating points during your exam, which is Section 2, the method mark strategy. This is where we shift our focus entirely away from just the final product and on to the mathematical process itself. The absolute crucial point here, straight from the source, is that marks are awarded for process. This is a total game changer, especially if you're someone who often finds yourself making tiny, frustrating arithmetic errors at the very end of a massive calculation. Your step-by-step methodology and your clear, documented working are just as valuable, and honestly, sometimes more so, to the examiner as your final numerical answer. If you show the correct methodological pathway to find a normal equation, you are banking marks, even if you fumble a negative sign on the very last line. You have to show them the code. But to actually secure those process marks, you must execute precise data interpretation skills. This involves extracting the key elements from the given text or data tables. It means interpreting the mathematical relationships, like quickly recognizing that a normal is perpendicular to a tangent, and therefore their gradients multiply to -1. And then you have to draw evidence-based conclusions. Literally everything you claim on that exam paper must be backed by the mathematical evidence shown right there in your working. So how does this method mark strategy actually look in practice when the clock is ticking? It builds into actual execution, which is Section 3, using a 5-step systematic process. This is basically the practical engine of your entire exam strategy. This standardized sequence practically guarantees a logical, bulletproof workflow. Top candidates follow this exact 5-step systematic sequence every single time they tackle a problem involving gradients, tangents, or normals. First, they identify the key elements. What is the curve equation, and what's the given point? Second, they apply the relevant principles, like differentiating to find the gradient function. Third, they execute the analysis with incredibly clear working. Fourth, they verify their results. And fifth, they ensure they present the final equation in the specific format requested by the question. It is a machine-like methodology that totally eliminates panic. And hey, quick reminder before we move on, if you want to master these frameworks, make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Hit that button right now so you don't miss our strategy sessions. Okay, let's keep going. Even with a great system, things can obviously still go sideways. That brings us to Section 4, the traps. Avoiding common pitfalls is literally just as important as knowing the right procedural framework. And thankfully, the examiners have explicitly told us exactly where students mess up year after year. The principal examiner reports outline these top 3 traps where candidates just throw away perfectly easy marks. First, forgetting to include the proper format. Second, forgetting to double-check that format and the overall presentation of the answer before moving on. And third, providing generic answers that are not specific to the given context of the problem. For instance, if a question asks for the equation of a normal in the form ax plus by plus c equals 0, and you just leave it in y equals mx plus c form, you are unnecessarily losing marks despite doing all the hard calculus perfectly. It's such a completely avoidable mistake. There is also this massive examiner alert to pay attention to. The reports explicitly warn that candidates consistently confuse key terminology. Applying the appropriate terminology, like truly knowing the strict mathematical difference between the gradient of a curve, the tangent, and the normal, is strictly required to maintain professional academic standards. Don't just throw math words around hoping something sticks. If you're writing an extended response or a justification, you need to define your terms clearly through your mathematical working. All right, for those of you aiming for the very highest tier of marks, we finally arrive at Section 5, the master key. This is all about achieving evaluative mastery. This is how you distinguish yourself as an absolute elite candidate in additional mathematics, 0606. Top-scoring candidates achieve this elevated level by actively demonstrating evaluative thinking. This means you question assumptions, you consider different mathematical perspectives or even alternative methods of solving the problem to verify your work, and, above all, you consistently justify your methodological decisions with solid mathematical evidence. Elite candidates don't just calculate blindly, they evaluate the validity of their entire route to the solution. Furthermore, when a question requires any sort of comparative analysis, like comparing the gradients of 2 different curves at an intersection point, for example, it is absolutely essential to highlight the similarities and the differences. You need to utilize comparative connectives to draw firm, evidenced fact conclusions about their relative relationship. Doing this shows the examiner that you have complete, unshakable command over the geometric interpretation of your calculus. So as we wrap up this explainer, I want to leave you with a real challenge. One highly effective memory hack is the visual story method. It's where you create a mental, step-by-step visual narrative of a curve, drawing the tangent brushing against it and the normal piercing through it at a perfect 90-degree angle. How will you use this visual story method to permanently encode these systematic processes into your memory? Ask yourself how you'll apply this exact blueprint, the 5 steps, the method mark strategy, those critical examiner warnings, to your very next past paper practice. Keep analyzing the code behind the questions, keep evaluating, and keep mastering those fundamental principles. And remember, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Drop a comment below with your target grade and the biggest challenge you're facing right now. We respond to every comment. Ace the Exams, your Cambridge success starts here.